Kubernetes. In this video, we will see exactly how to actually deploy an application on Kubernetes, YAML files, deployments, services, and Ingress. We will start with a single YAML file, and by the end, we will have an application that will be live and reachable from the internet. My name is Diego, I'm a senior DevOps engineer based in Paris, and I like breaking down tech concepts into simple and visual explanations. If you want to see more videos like this one, feel free to subscribe, and that's all. Back to the video. This is the part 2 of the Kubernetes series. In the part 1, we saw that Kubernetes is the conductor behind your containers. We explored how Kubernetes works, its architecture, and how it takes your desired state and constantly works to make it real. All of that is Kubernetes' job. Your job is to define that desired state. And that's exactly what we are covering today. Before we continue, let me tell you about the sponsor of today's video, Plural. Learning Kubernetes is one thing. Running it in production is another. Now you are managing clusters, alerts, tickets, upgrades, so you end up spending your days in all these tasks. But your job is to build cool things, not to spend your days fixing them. Plural is an AI platform for managing Kubernetes, and they just released something called Workbenches. Workbenches are AI DevOps agents that you configure once, and they run in your own cluster. Let's say there is an alert firing. The agent investigates the logs and the metrics on its own, finds the root cause, and opens a pull request with the fix. By the time you even look at the alert, the investigation is done, and the fix is already waiting for your review. Same thing with tickets. Someone creates a Jira ticket to resize a database. The workbench starts working on it automatically, finds the right Terraform, makes the change, and links the pull request back to the ticket. What I really like about Plural is that the agent never touches production directly. Everything goes through a pull request that a human reviews and approves, so you stay in control. Thanks to Plural for sponsoring this video, link is in the description. Now back to the video. Everything in Kubernetes starts with a YAML file. YAML is a simple format for writing configuration files. You use it to describe what you want Kubernetes to create. But here is something important to understand first. When Kubernetes receives your YAML file, it creates something called an object. An object is just a resource that exists inside your cluster. And there are different types of objects, a lot of them. Each object has a specific role, and you combine them to run your application. But don't worry, we are going to start with essential objects today. And as your knowledge grows across this series, we will explore more. Before we create our first object, let's look at the anatomy of a YAML file. Every Kubernetes YAML file has 4 main parts. First, API version. Kubernetes updates its features over time, and this field tells it which version you are working with. Second, kind. This is the type of object you want to create, like pod, deployment, or service. Remember, there are a lot of them. Third, metadata. This is where you give your object a name and add labels so Kubernetes can identify it. And fourth, spec. This is where you tell Kubernetes the details about your object. These parameters change depending on the type of object you are creating. Things like which container image to use, which ports to open, and how many replicas to run. API version, kind, metadata, spec. This structure is the same for every Kubernetes object. Some of them have small variations, but once you learn this structure, you will recognize it everywhere. Let's start with the simplest object, pod. A pod is the smallest thing you can deploy in Kubernetes. It packages one or more containers, so that Kubernetes can manage them. Here is a YAML file that creates a single pod running an nginx web server. The kind is pod. The metadata gives it a name, and the spec says, run one container, use this nginx image, and open the port 80. So now that we have our YAML file, how do we actually send it to Kubernetes? Remember the API server from the part 1, the front door of Kubernetes? Well, that's exactly where this file needs to go. And you can connect to that front door in many ways, with different tools. We are going to use the most basic one, Kubectl. Kubectl is a command line tool that connects directly to the API server. You use commands like kubectl apply to create stuff, kubectl delete to remove stuff, kubectl get to check the status of your pods. You can do basically everything. So we run kubectl apply, point it to our YAML file, hit enter, and Kubernetes creates our pod. Pretty cool, isn't it? But there is a problem. If that pod dies, nobody replaces it. It's just gone. We created a single pod by itself, and Kubernetes has no instructions to keep it running. And that's why in practice, you almost never create pods directly. Instead, you use something called a deployment. A deployment is an object that manages pods for you. You tell it how many replicas you want, and it keeps that number running. If a pod crashes, the deployment creates a new one. If you need 5 replicas instead of 3, you update the number, and the deployment makes the adjustments. Let's look at the YAML file to understand how it works. Notice something different? The spec has changed. It now has a replicas field, a selector, and a template. Replicas is how many copies of your pod you want running at the same time. The template is where you describe the pod itself. Look, it's the same container we used before. It's just that now it's placed inside the deployment. The selector tells the deployment which pods it should manage. See these labels in the template? The selector looks for pods with those exact labels. That's how the deployment keeps track of its pods. So a deployment is basically a YAML file that contains the instructions to create and manage pods automatically. You use kind pod to run a container directly, and kind deployment to keep your pods alive and scaled. Okay, so now we have our app running in multiple pods. But how does traffic actually reach them? Time to meet our next object, service. Every time a pod is created, it gets a new IP address. If a pod dies and a new one replaces it, the IP changes. So anything that was connected to that pod cannot find it anymore. A service gives your pods one stable address that never changes, no matter how many pods are behind it. It's really cool because it also acts as a load balancer, balancing traffic across all the pods behind it. In the YAML, the kind is service, and it also uses a selector to find the right pods by their labels. So instead of connecting to a pod directly, you connect to the service. Pods can die and be replaced, and the service keeps the traffic flowing. Now our app is running. It's managed by a deployment, and other apps inside the cluster can reach it using our service. But what about users outside the cluster? For the moment, our app is only reachable from the inside. For that, we need a new object, Ingress. Ingress exposes your existing services to the outside world. It's the entry point of your cluster. When someone visits your application from the internet, Ingress decides which service should handle the request. For example, if your app has a frontend and a backend, you can say, requests to this path go to my backend service, and requests to this other one go to my frontend service. In the YAML, the kind is Ingress, and in the spec, you define those routing rules. And that's all you need to get your app reachable from the outside. So let's put it all together. You write a YAML file. You send it to the Kubernetes API server using Kubectl. A deployment creates and keeps your pods running. A service gives those pods a stable IP address inside the cluster, and an Ingress exposes them to the outside world. A user types the URL of your application in a browser. That request arrives to the Ingress. The Ingress decides which service should handle the request. The service picks one of the available pods, and if that pod ever crashes, the deployment replaces it with a new one. And just like that, everything just keeps running. In the part 3, we are going to take this further. We are going to keep building on top of what we have learned today. These videos take me weeks to produce. A simple comment helps the video reach more people. I will appreciate it. Thanks for watching and see you in the next one.